Okay, we are now reaching the last slide of this chapter, which is system. So since we don't have the practical lab to do the practical in connecting and assembling all the StandAlone system, we are only capable to do it on this slide only. So I'm going to teach you a very basic connection for StandAlone system. Hopefully, you are going to like this, so hopefully it can be it help you. Okay, basically we are going to connect our PV module, battery and load to the charge controller. The charge controller is very important here. So basically these two holes are for the PV, so these two are for battery, and these two holes are for the DC load. Okay, DC load. Okay, how to connect it? It's very simple. Let's say we have the plus here, so we just pull the plus cable here and put it here. Okay, then we pull the minus cable, negative cable, and put it here. So means that this is plus and this is minus. Okay, now we finish. Next is the battery part. So the battery part, so this is the plus, so we connect it here. So this is plus positive terminal, and this one for negative terminal. Okay, so this for negative terminal. Okay, what happened to the DC load that we have here, and we also another AC load and inverter? What should we do? So so this DC load, usually the rated voltage for the DC load is 12 volt. So that's why, because all are 12 volts, so we just connect it in parallel so that we get the same 12 volt voltage output. Okay, like this. Okay, so assume this is the plus, so this plus we connect it here, and the negative part, so we connect it here. Okay, so we get positive and negative. Let's say you want to put the switch. So, okay, you can put switch each of this. Okay, each of this. Alright. Okay, next, inverter. What about the inverter? So the correct connection is to connect this inverter to the DC load part. Actually, there's another way to connect the inverter to the system, which is direct to the battery, but you need to put the circuit breakers and other system also to control from overcharge or over discharge, not to control it from the over discharge of the battery. But the correct one is to connect directly to the DC load part, which is in the same way as the DC load but parallel. So this plus cable, and the negative one also connected here. Okay, so this is the negative one. What is very important, if the battery is not enough, the battery will shut down the load, turn off the load, so that the battery will not become over discharged. So that's why the charge controller itself will control this kind of things, because the function of charge controller is to control the battery state from being overcharged or over discharged. So that's the function, the main function of charge controller. That's why when the battery is over almost reach the bottom level, so it will turn off automatically the DC load. That's why when it is turned off, the inverter also will turn off, so no current will be withdrawn from the battery. Okay, so we put it here, and then the output of the AC, everyone knows, they can, maybe you can just put the, we have three, of course we have three terminal here, where sometimes there's output for the grounding here for the inverter. Then you can connect into the socket outlet. Okay, socket outlet. So you have the socket outlet here. Okay, socket outlet here. Then connect it with your appliances, your AC appliances. Okay. Accordingly to the line, the live, ground, and the neutral wires. Okay. Okay, this is very basic, but basically, actually, you need to put the switches fuse. Okay, where to put the fuse. Usually we put fuse here between panel and charge controller. So this and the fuse plus and minus both, we put fuse both plus and minus. Okay, and then that one is, even though we have charge controller, like I told you, we cannot rely 100% to charge controller. You must have the separate switches. So for the battery also, we put another switch. You can put the direct DC MCB. Okay, DC miniature circuit breaker. So DC MCB. So this one also DC MCB. Okay, for battery. And for battery, so the MCB for both positive and negative cables. Okay, same case also with the inverter. You should put everything must be put the meter circuit breaker also DC. Okay, so this one also you can put DC MCB, and this one also you put the DC MCB. Okay, it's the same. Okay, the rated is depends on your load. For example, you can put 10 amps, 15 rated, or 20, 30, it depends on you. Okay, same case also with the DC load. Even though we can rely on that, but at least we have the backup. So also we put as the same like circuit AC. Also everything must be put with the DC, both plus and minus. So you put here also DC MCB. Okay, DC MCB. Alright. Okay, there's one missing here. Okay, there's one missing here. Actually, you need to put another things device. We call that as SPD. Okay, we need another one, which is the SPD. So that SPD basically is connected parallel many things. Usually, there's one connection here that connect. It's okay. I put another wire. It's same. Just put another different wire from the PV module here. For example, we put here plus here, and we put negative here. I forgot the sequence of the connection, but one, there's 3 hole here. Okay, there's 3 hole here. One is to connect positive and negative. Okay, one is to connect positive and ground. Okay, mean the second, the first one positive, negative. Second one, sorry, I forgot the sequence. Which part is the positive, negative? Positive and ground. Another one is negative and ground. So this SPD or surge protection device is very important to prevent the lightning, any short circuit or breakdown due to the lightning. Okay, we call that SPD. It's usually connected before the charge controller. After the PV module, directly we connect it to the SPD. Okay, so we have ground here. So this one also connect with the ground, and the ladies have 1, 2, 3.